The properties of the refractories and the refractory materials are important and fundamental to the development, improvement, quality control, and selection of refractory linings for the high-temperature processes, where the wrong choice leads to refractory failure. In this course, some important points will be explained. Defining the causes of refractory failure. Course 1. The video below shows the places refractory bricks and castables are used. 1. Upper cyclones. 2. Lower cyclones. 3. Calc inner. 4. Inlet chamber. 5. Tertiary air duct. 6. Rotary kill. 7. Kill hood. 8. Cooler. This video explains how to repair the cooler after castables fall out of it, as well as how to weld refractory anchors. And the video shows the different types of refractory anchors used in the cooler, which is the area outlet, the rotary kill. The video shows the castable refractory casting method. Castable refractory cement is a dry mix material, so mix it carefully, cast properly, and then dry it completely. It can be shaped into custom shapes, to meet individual requirements. Let's first ask this question. What is the functions of refractory lining? 1. Protection of the kill shell and tires from overheating and subsequent deformation. 2. Protection of the kill shell from chemical attack. 3. Protection of the kill shell from mechanical abrasion. 4. Thermal insulation. 5. Increase of heat exchange. 6. Control of material flow. 7. Control of coating behavior. Our main goals in cement industry. A. To maximize production. B. To minimize production costs. C. Understand and control the process, at all stages. 1. The major reason for production team cannot achieve their target is unplanned kill stoppage, due to refractory failure. 2. The installation of the refractory is one of the main criteria, affect brick service. 3. Bad and unprofessional installation. Techniques followed by unprofessional heating up and cooling down schedules can cause premature of refractory materials. Performance targeting. Most cost-effective refractory solution, to protect the kill shell and reduce heat loss. 1. Price. 2. Performance. 3. Predictability. 4. Planned repairs only. 5. Fit in with other repairs. 6. Continuous improvement, year-on-year saving. Installing of monolithic refractory. This type of lining has increased in the last years because 1. Easy to apply in kill system in short time. 2. Can be adapted to any shape and size. 3. Monolithic refractory will acquire their final properties by following: proper storing and installation, availability of applying mechanical equipmentus, chemical and alkali attack, high thermal shock resistance, proper drying procedure, and enough setting time. Proper anchors and their applied, welding electrode, suitable length. Installation under experienced team. General information about monolithic materials. Delivery place. Manufacturing date. Shelf life and storing period. Application temperature. Cold crushing strength and grain size. Water ratio and mixing time in mixer. Chemical composition. These information should provided by supplier. Preparation for installation. 1. Location and total size of area, need to cast. 2. Anchor type, length, thickness, and quality. 3. Number of anchors, and their distribution as drawing. 4. Type of welding electrodes. Example for anchor which withstand up to 1150 degrees. Nickel ratio 18 to 23%. Chrome ratio 24 to 26%. B continues. With working temperature low, we use anchors with lower percentage of chrome and nickel. Expansion joints must be distributed in all area to be sure there is enough flexibility. Keep the dimension of each casting mold less than 60 cm or 80 cm. General rules. 1. Anchors should have enough expansion. 2. Water content applied as supplier recommendation. 3. Venting holes in castable mass, to permit for the vapor escape. 4. Proper heating up of castable, depending on the following. 5. Castable grade and water quantity. 6. Thickness of castable mass. 7. Condition at construction country, such as ambient temperature. Water quantity and venting holes in castable. Please read these very important notes. 1. If water quantity not controlled, castable mass will start to explode during heating up. 2. If venting holes are forgotten, explosion castable will take place. 3. High amount of water during mixing will make amount of washed, and during mixing castable will lose the binding. 3. Element and crake will appear. 4. Why it not applied the castable after shelf lifetime. Formation of layer in the mass of concrete. Cause: uncontrolled interruptions to work, or working fields too large. Effect: a monolithic body form as the layer installed, after each interruption does not adhere optimally to the adjacent layer which has already partially or completely set. The same applies to working fields, which are too large as the quantity of mix is not sufficient and new mix has to be prepared. Remedy: complete each field in a continuous working pattern. Formation of layer. See in this figure. Spalled monolithic layer, due to formation of layers. Damage of nose ring castable. Nose ring castable destroyed, kill shell deformed. Cause: 1. Lack of compensation for expansion, retaining ring to take longitudinal expansion, not provided or unsuitability constructed. 2. Unsuitable type of monolithic refractory. 3. Incorrect installation. Remedy: 1. Rebuild retaining ring. 2. Use a higher and quality refractory grade. 3. Comply with lining instruction. Destruction of monolithic lining in nose ring. This video shows the destruction of monolithic lining nose rings. Destruction of nose ring castable, by shrinking and abrasion. This image shows destruction of monolithic lining nose ring by shrinkage and abrasion. Cavities on the surface of castable mass. Inhomogeneities within the structure are visible after removal of shuttering. Cause: 1. Insufficient mixing. 2. Forced action mixer not clean. Remedy: 1. Comply with specified mixing time. 2. Use clean forced action mixer. Air cavities are found in the concrete mass. Shrinking cavities visible after removal shuttering. Cause: insufficient venting. Remedy: use pneumatically or electrically driven vibrator must be used. Castable mass is not regular in structure. Castable has an irregular structure and inadequate strength. Cause: 1. Insufficient mixing. 2. There is a locally varying composition, degree of setting and strength. Remedy: use clean forced action mixer. Sever cracks in castable mass after heating up of rotary kiln. Monolithic lining is covered with shrinkage cracks after use. Cause: 1. Thermal load. 2. Unsuitable mix grade, which is thermally overloaded as a result. Remedy: 1. Adjust product to the load occurring. 2. Avoid temperature peaks and dense sintering. Spalling of castable mass in thick layer. 1 to 5 cm, thick surface spalling on heating up. Cause: 1. Heating up too rapid. 2. Surface subsequently concreted. Remedy: 1. If only thin layer have spalled, there is no risk to installed section. 2. If thick layer have spalled, this part has to be repaired by gunning. 3. Slow heating up. 4. Complete each field in a continuous working pattern, and avoid uncontrolled interruption to work. Failure of castable around first part of main burner. Premature collapse of castable at tip. Cause: 1. Unsuitable construction. 2. Insufficient or unsuitable anchoring system. 3. Impact stress. 4. Chemical corrosion and alkali. 5. Coating fragments falling off. Remedy: 1. Choose a tough refractory concrete. 2. Suitable anchors be used. 3. Proper installation of refractory. Burner tip refractory failure. Unsuitable anchoring of monolithic refractory at burner nozzle tip. This is a very important course, and I hope it will benefit you. If you have any questions, thank you for watching, and I hope these courses are helpful to everyone. Subscribing to this channel cement industry courses would be appreciated. Thank you.